Hello and welcome back to our welding educational video series. I'm Randy Emery. I'm a welding educator at College of the Sequoias in Tulare, California. And today's lesson will be, what is the GMAW process? In this lesson, we will take a look at basic process variables, some of the limitations and advantages, and we'll have a short lab demo where we'll show you the equipment and some basic controls. What is the GMAW process? GMAW stands for gas metal arc welding. And this is the standard term that is used to describe this process. Some of you may be familiar with the non-standard term, or MIG welding, which stands for metal inert gas welding. But this is actually incorrect because some of the gases used are not inert. The GMAW process uses a solid wire electrode and is shielded by an external shielding gas. This shielding gas will protect the weld pool during solidification and the cooling down period. So now that you know some of the basics about the process, let's take a look at the process advantages. The GMAW process can be used on a wide range of metal thicknesses. The GMAW process can also weld a wide variety of materials and base metals. Because the GMAW process uses a continuous wire electrode, the GMAW process has a very high efficiency of deposition rate. The GMAW process is also used in all positions. Because the shielding gas is used with the GMAW process, there is no slag, which could become a quality control problem. This is definitely an advantage of the GMAW process. Now let's take a look at the GMAW process limitations. Because the GMAW process requires more equipment than the SMAW process, it is not very portable. Any welding process that uses a shielding gas, such as the GMAW process, will likely encounter welding problems when used outdoors due to outside air interference. When the GMAW process is used, the base metal must be fairly clean as well, another limitation. The GMAW process has been known to have fusion problems when welding thicker materials. This can also be a serious limitation. Now I'd like to cover the AWS classification for the GMAW process. The first letter will be an E, which stands for electrode, because a welding current is carried through the electrode. The next letter will be an R, which stands for rod, which doesn't really pertain to the GMAW process, but this classification system is also used for GTAW welding, so the rod classification will apply to that process. The next two digits, possibly a 70, stands for pounds of tensile strength times 10,000. The S indicates a solid electrode. And the final digit will give you an idea of the chemistry of the filler metal and a little bit about the amount of deoxidizers contained in that filler metal. Now that we've spent a little time in the classroom learning about the GMAW process, I thought we'd come out here into the shop and take a look at some of the GMAW equipment. And here you have your basic GMAW welding power source, something that you can pick up at your local hardware store for $300 to $500. As you can see, it has a very small drive roll system, and the drive roll system is used to pull the wire off of the spool, and it feeds it to the business end of the MIG welding gun. And after that, you would probably want to look up and find your material thickness on this handy chart that the manufacturer provides. Here we have 18 gauge material, and we're using a 030 wire with a CO2 shielding gas. And it's very simple to find our settings. Here we have F4. And what does that mean? Those are factory correspondence to wire speed and voltage. Here we have the control panel of this power source, and after using the selection chart, which gave us the parameters F4, that should give you a great starting point as far as voltage and wire speed to start welding on 18 gauge. As you can see, this model is a much more industrial model and very sophisticated compared to our basic model that you just seen. It can contain up to 150 pre-programmed welding schedules. In just a moment, we'll show you how to access and begin a search to find your specific welding schedule. Here we have a 4-drive roll drive system. And one thing that the welder must be aware of, what is the size of the drive roll? Be sure that the drive roll size matches the filler metal diameter. And once that is determined, we can feed the wire through. Be sure the drive rolls are locked in place and the retaining cover is on. Once that's done, we need to determine the drive roll tension and refer to your manufacturing recommendation for the specific wire you're using to set your drive roll tension. Here's another variable that the welder must consider. Here we have a typical spool of GMAW wire. What diameter are we working with? Needs to be the first question asked. The second question is, what AWS classification does the wire come under? And here we see this is ER70S-6. So a well-trained welder should be able to determine that this is acceptable wire for the application. Another very important variable the welder must know about is shielding gas. What type of shielding gas do we have? What type is required? And what about flow rates? Here we have a typical cylinder with a flow meter. Once you crack the cylinder open, the gauge will show you cylinder pressure, and then after the cylinder pressure is verified, we need to adjust our flow rate. And later on in our series, when we talk about welding techniques, we'll get into more depth on what flow rate is needed for a given process. Here we have the main control panel of the power source. Let's take a look at one very important feature. This power source has a weld mode search feature. What we do is we turn it down to 0, and it gives us a beginning search message. We'll begin our search by verifying that we are looking for a synergic CV GMAW process. That is correct. Okay. We are working on steel. That is correct as well. We are using a 0.35 diameter wire. It's correct as well. And our shielding gas is not CO2, but it's a argon mix. So we'll see what it does for us. It takes us directly to mode 11, and it gives us some very good starting parameters for our welding. You can take this and you can adjust it. You can go outside of the recommendations, or you can go below the recommendations. As you can see, the synergic feature, and what that means is you only need to adjust one parameter. You need to adjust the wire speed, and the voltage will be adjusted for you. Okay. Another very attractive feature of this power source, you can see the 6 buttons we have in the middle here. We have procedure A or procedure B. We can program up to 12 preset welding modes or welding schedules into these buttons simply by holding it down. See, the light goes off, and now we just save that set of variables into mode 1. To finish up your notes, I want to show you a few detailed variables a welder needs to consider when using the GMAW process. The first item shown for the GMAW process is the shielding gas in. This shows the tube used to convey the shielding gas from the compressed gas cylinder and delivering it to the welding gun. The next item is the contact tip. This is the threaded tip that screws into the gas diffuser at the end of the welding gun. The size of the contact tip must match the welding wire diameter. The next item is the electrode. This item is sometimes referred to as the welding wire, but technically it is an electrode because it is carrying a current. Like most of the other processes, the GMAW electrode mechanical properties should closely match the mechanical properties of the base metal. And the fourth item on the slide is the weld pool. And like other welding processes, this is where the heat of the arc melts both the filler metal and the base metal to create the weld puddle. The next item is the solid weld metal. This is describing the weld pool after it has solidified. The size of the weld metal is a direct result of welding technique and welding travel speed. The next item on the slide is the arc. This is another variable that most welding processes have in common. This is where the heat is generated to melt the base metal and the filler metal. Arc characteristics are a very important variable to understand in the GMAW process. Once the welder learns about the various transfer modes that are possible with the GMAW process. And the next item is the shielding gas. This shielding gas is supplied from the external compressed gas cylinder, and correct gas selection is very critical due to the fact that shielding gases will affect penetration, bead profile, spatter control, and arc characteristics. The final item on the slide is the direction of travel. The direction of travel is an important variable because the welder will need to adjust welding gun angles to establish proper welding technique and maximize welder comfort. These are a few of the variables a welder needs to be comfortable with when performing the GMAW process. So that's all we have for you today. Please be sure to check out our next segment where we'll take a look at the FCAW process. Thanks for watching.